All right, here we have another example from functions 3, very similar to the homework. All right, this function does kind of just takes every natural number so let's see, you have, let's do some, you got 0, 1, 2, dot, 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 and then the power set, right, sends 0 over to the set containing 0. 1, it goes over to the set containing 1. 2 goes over to the set containing 2. And so on. Okay, so filling out the table. I think this will definitely be easier for you with a pen than with a stylus. Okay, now let's see, what goes over to the set containing 25? You guessed it. 25 goes over like so. Now what comes over to the set containing 1, 2? Nothing. All right, so this does not exist. Ooh, I don't know what that was. Okay, does not exist. All right, so there's plenty of things over here. There's plenty of things in the power set of the natural numbers. Remember, the power set is a set of all subsets. All right, set of all subsets of the natural numbers. Remember, the empty set is a subset of all sets. There's nothing that comes over to that. Right. Similarly, the set 1, 2 doesn't have anything that comes over to that. Okay, so not everything in the target gets hit. Not everything in the target gets hit. So this is not a bijection. Right, remember, a bijection is a function that is both one-to-one and onto. A function is onto when everything in the target gets hit. Well, here we found not everything in the target gets hit. There's lots of things in the target that don't get hit. The only thing in the target, the power set, the set of all subsets that get hit, is all the what we call the singletons, the sets with only one element in them. The set containing 0, the set containing 1, the set containing 2, the set containing 3, the set containing 25. These all get hit by our function, but 2-element subsets, 3-element subsets, 5-element subsets, none of these get hit. All right, so f is not a bijection. And remember, f inverse is a function if and only if f is a bijection. So it means the same thing. They're synonymous ideas. F inverse is a function, means the same thing as f is a bijection. F is a bijection means the same thing as f inverse is a function. So if f is not a bijection, f inverse is not a function. Remember, if you fill out this one, you have to fill out that one. If you fill out that one, then you have to fill out that one. They're the same thing. They're equivalent ideas. All right, so now, so we're done with the worksheets, or we're done with this example, but just to bring up another point, is our function here, is f 1-to-1? So is f 1-to-1? That's the question, right? So remember, you're not 1-to-1 if you have something that looks like this. Right? You have two inputs going to the same output. All right, so now it looks like from our table, right, that there's no two different inputs going to the same output. And if you think about it, that's not going to happen, right? So in this case, f is 1 to 1. But f is not a bijection because it's not onto. Right, so f is 1 to 1, but it's not onto. It has to be both 1 to 1 and onto to be a function. So because f is not 1 to 1, it's not a bijection. If it's not a bijection, its inverse is not a function.